So we have learned the basic of number pattern. In this lesson, we will go into more advanced stuff, which is not your basic general term. Your basic general term, we learned that is Tn is equals to term 0 plus Dn. So other general term will be more complicated than this. So let's get started. So today, I will learn how to solve number pattern with other general term. And the key is, look at what is added to term 0 plus dn. But just take note, it doesn't have to be added. It can be subtracted, minus, times, divide, or even square. So let us start off by looking at some number pattern that have other general term. So simple question. Find the first three terms of each sequence from the given general term. So A is something that we are familiar with. If we want to find what is the first term, so what we need to find is the first three terms lah. T1, T2, and T3 for all. So very simple. For this, we just substitute 1 into n. So T1 is equals to 2 times 1 plus 3. So this one will be equals to something, while T2 will be equals to 2 times 2. So where did I get this 2 is from here. The 1 is from here. Plus 3 is equals to something. And finally, T3 is equals to 2. Make a smart guess. What do we multiply? Since this is term 3, we multiply by 3. Plus 3 will be equals to something. So 2 times 1 equals 2. This one will give me 5, 7, and 9, or 1. So the first three terms is 5, 7, 9. So this is what we have been doing for the last few lessons. The next one is slightly more complicated, but the procedure is the same. It is just basic algebra substitution. So term 1 is equals to n, we change into 1. So 1 square minus 0.5 times 1. So I will get 0.5. Term 2 will be equals to 2 square. The 2 come from here. Minus away 0.5 times 2. The 2 come from here, or came from there. So I will have 4 minus 1, then I will get 3. And finally, term 3 is equals to 3 square minus 0.5 times 3. And I will have 9 minus 1.5. So I will have 7.5, and the first three terms will be 0.5, 3, as well as 7.5. Lastly, if you want to try this out, you can try it out. Pause the video and try the question out. And when you are done, let's unpause and do this. So term 1 is equals to n, we change into 1 because this one is replacing the n. So I will have 1 square plus 2 times 1 minus 1. So I will have 2. Term 2 is equals to 2 square plus 2 times 2 minus 1. equals to 2 times 2 equals to 4, 2 times 2 equals to 4, so 8 minus 1, I will get 7. So term 3 will be equals to 3 square plus 2 times 3 minus away 1 is equals to 14. So the first three number will be 2, 7, as well as 14. Alright, I hope you have got the answer correct. Let's move on. So please try these 3 questions out yourself. Pause the video and try them out. And when you are done and you want to check the answer, they are down here. So these are just simple questions. Let us move on to question that is a lot more difficult. So let's take a look at a more difficult question. The general term of a sequence is Tn is equal to 2n squared. Write down the first 4 terms of this sequence. So you should be very familiar with this. We just went through, and this is something that looks easier. So for A, term 1 will be equal to 2 times 1 squared, and this will give me 2. And term 2 will be equal to 2 times 2 squared, which will give me 8. And term 3 will be equal to 2 times 3 square. Where do I get this 3? I got it from here. So you should be able to see the pattern now. Whatever that's inside the bracket, the unknown have been converted into the position they occupy on the number pattern. So over here, I will have 9 times 2, I will have 18. And finally, let's look at the term 4. Is equals to 2 times 4 square, and I will have 32. Alright, so the first 4 sequence, I can see there is 2, 8, 18, as well as 32. The first 4 terms of another sequence are 5, 11, 21, and 35. Suggest a formula for the general term of this sequence. So you can see that 5, 11, 21, and 35, actually they do not have any common difference. So you are kind of stuck as to what to do. But let's take a look at the key. Look at what is added to term 0 plus dn. So this is your kind of like your general term, or the first 4 terms of the sequence. What you need to do is to compare 2, 8, 18, 32, 5, 11, 21, and 35. What is so common between the numbers that are on top and the numbers that are below? See if you can find any pattern. Now, if you are sharp, you should be realized that 32 to 35 we plus 3. 18 to 21 plus 3. 8 to 11 is plus 3. 2 to 5 is also plus 3. So what this means is, since the general sequence of the number pattern is this, the new sequence will just be term n is equal to 2n squared. So you can see that this is the original number pattern. The equation is down here. What we are trying to do down here is only just add 3 to everything. Can you see? Add 3, add 3, add 3, add 3. So term n will be equals to 2n squared plus 3, because you can see that the new sequence is the old sequence, but everything plus 3. And find the 20th term of this sequence, quite easy. Term 20 is equals to 2 times 20 square plus 3. So I will get 803. Okay, if you are unsure, copy this down. If you are sure, also copy this down as reference. If not, we are moving on. The next example looks rather lengthy, but it is actually quite manageable if you look at it parts by part. And if you look at the first part, part A, you actually have been doing it all along. The first 4 terms in a sequence of number are given below, 5, 8, 11, 14. Express n term in terms of n. So it is what we learned at the start. And to do this, what we need is the information of what is the common difference. So you can see that from 5 to 8, 8 to 11, 11 to 14, everything is plus 3. So we know that D is equals to plus 3. The common difference is plus 3. The next information that we need is what is term 0. So what number add to 3 will give me 5. So I will have 5 minus 3 and I will get 2. So term n will be equals to term 0, which is 2, plus common difference is 3, and n. So this will be the answer. Voila. The next part, another sequence is given below. Find the value of term 5. So at first, if you look at this, term 1 is equal to 6, term 2 is equal to 12. There's no real pattern. But recall the key. Look at what they add to the term n. This is actually term n because term n is equal to this. What they are adding to term n is actually 1 square, 2 square, 3 square, and 4 square. So how do we calculate term 5? Is quite simple. Now, term 5, it will be 5 square. And if you didn't notice, this sequence, 5, 8, 11, 14, it is the same as the sequence they have given above. So the question of part A and part B are most likely related, so that we can have an easier time answering it. So you can see that 5 to 8 is plus 3, everything is plus 3. So 14 plus 3 is equals to 17. So term 5 will be equals to 5 square plus 17. And I will get 25 plus 17. And my answer will be 42. Then find the n term of the sequence. Now, if you haven't noticed, or you have been sleeping because I have been talking about this, this sequence down here, the general term is actually this. So all we have to do is to add this to this equation. So let me just erase and make it clearer. So when n is equals to 1, I have 1 square. N is equals to 2, I have 2 square. N is equals to 3, I have 3 square. So when n is equals to n, I will have n squared. So all I have to do is to add n squared to this equation. So look at what is added to term 0 plus dn. So for this term n will be equals to n squared plus 2 plus 3n. And that will be my answer. Because this part is actually this part, while the n squared is actually this part. Finally, find what is the 30th term of the sequence. Very simple. Term 30 will be equals to 30 squared plus 2 plus 3 times 30. And I will have 30 squared, which is 900 plus 2 plus 3 times 30. And my answer will be 2, 992. Alright. So it requires a bit of observation. Like you need to see that, oh, this sequence is actually this sequence down here. And this sequence down here, we have already found in part A. This is the n term. And all we have to do is add n squared to the answer in part A. And we will get this. Alright. Next, try the question out. Pause the video and try. And if you have done it, here's the answer for you to check to see whether you are correct or wrong. So once you are done, it is